Hello everybody, this is Unit 2, Day 1. We're going to go through Day 1 stuff right now. I was really hoping to be in class today. This is not a lesson that I typically enjoy to do virtually with you, but we're going to have to do the best we can because I'm obviously out. So we're going to go through a pretty new concept for everybody, points, lines, and planes, and then you can see here as well at the end of the lesson you'll have a little bit of a assignment on formative. So we'll kind of go through that at the end as well, but you'll be able to see that on Canvas. So like I said, we're going to go through Day 1, points, lines, and planes. I've got some of this filled out. I don't have a lot of it filled out, but just a few things, just because we're going to go rather quickly through some of the first stuff. Like, for example, for a point, that's something that we're all pretty familiar with. It's a location. It doesn't have a shape or size. Just like if you had a coordinate plane and you were placing a point on it, it doesn't matter how big you make that point. It's just pointing to a location. It's typically looking something like this. And importantly, I would like to point out here that it needs to be a capital letter. So if I were to name what I see over there, I could just call it straight up A. I could also call it point A. So we'll have you write both of those down. Now, I'm going to be honest with you. You're probably not going to see me say or write point A very often, because if I can just say A, I guess writing the word point in front of it doesn't, it's just extra writing. So I typically go with just the singular letter A. But yeah, point A is another way you could do it. Moving on, we're going to talk about a line. Now, if I ask somebody to come up to the front of the board and draw a line on the board, I guarantee like 99% of the time, the person's just going to go like that and then call that a line and call it good. And to them, I would say that is incorrect. That is not what we're going to define a line as anymore. A line is made up of points. It has no thickness or width, and then there's exactly one line through any 2 points. But more detail on that is that line would be having arrows pointing out from both sides, meaning it's going to extend forever in both directions. And this line happens to have 3 different points on it, R, S, and T. So when I go to name it, this is super important because this is where a lot of people go wrong. When I go to name it over here, I'm going to name it with a line symbol above it, listing only 2 of the points. I will never name this line using all 3 of those that I'm seeing there. I'm only going to use 2. So I can pick any 2 that I want for a line. I'll pick R and S. And if I put my line over top, and that's what I'm calling a line now. Remember, a line has arrows on both sides. But if I'm going to write my line on top, that's what it could look like. Another thing I could do here is I could name it ST if I wanted to. These mean the exact same thing. I could have gone backwards with either of those letters. I could have gone RT, for example. That's another one. I could have flipped any of those around as well. Then if you can see over on the corner here, we've got a lowercase m. Well, that lowercase m is just another way to name it by calling it line M. Then you don't have to name 2 points. You don't have to do the arrows on top. Sometimes that's all you get is just that little little letter, that lowercase letter right next to it. So it's just another thing to look out for when naming a line. So this would be lowercase if I'm naming it like that. Again, points are capitalized. I think I said that up here. Points are capitalized. So when I write these, they need to be capital letters too. Moving on, we're going to go to a plane. Now, this is going to be kind of hard for me to explain over the screen to you, but I'm going to do my best here. A plane is a flat surface that goes indefinitely in all directions. So, for example, if you were to take a piece of paper and extend it forever in all 4 directions, like the left side of the paper goes forever, the right side, the top and the bottom extend, and it's perfectly flat, that would be a plane. Except it's probably even a little bit too thick because a plane doesn't have thickness. If you're trying to figure out what that would mean if a plane doesn't have thickness, think of a coordinate plane. That's why it's called a coordinate plane. It's got an x and a y axis. And if I came up to you and I said, how thick is the plane? Like, obviously, like, it goes left and right and it goes up and down. But how far, like, in and out does it go? You would tell me that's not a thing. It doesn't, because it has no thickness. So when you think of a plane, think of a coordinate plane. It goes forever here, 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 and here. Points that are on the same plane, I guess I did forget to talk about this up here. Points that lie on the same line are collinear. I remember it because points that lie on the same plane are coplanar. Kind of mean the same thing. If they're on the same line like that, you would say those are collinear. If they're not on the same line, let's say we have a point that's over here, like K, for example, point capital K, you would say it's not collinear with those other points. Continuing, with a plane, you could say it's coplanar or non-coplanar. Now this is a little tricky. We're going to go over to this picture here of a plane. This picture of a plane seems a little strange because I told you that it extends forever in all four directions. This way, this way, this way, and this way. I don't want you to draw those arrows on there because it's not really necessary to. But why wouldn't they draw it extended? Why did they put like edges on it, barriers on it? Well, that's because if I was drawing a picture on a piece of paper, how would I draw it so that it extends indefinitely in all four directions? It wouldn't really be possible. So they have to put borders around it. But I need you to think it doesn't really have borders. It goes on forever. This is just a way to conceptualize it. Then, these points that are on the plane, like this, I can tell that they're on the plane because they are inside of the bounds of the plane. What do I mean when they're on the plane? So if I had a plane that was kind of tilted, maybe a little bit more level, I don't even know how I would draw it, there could be points, there could be points above the plane or below the plane, and maybe the plane goes indefinitely forward and backward and side to side, but they would be above or below the plane. How do we note that? We just write them outside of the plane like this. Or here, or here, or here. Then you know for sure that those are not on the plane. They would have to be either above the plane or below the plane. It's kind of hard to explain. We might get into that more when I get back. But if I'm naming a plane, I would name it with 3 non-collinear points. I'll talk about that again when I get back too, because that's very tricky to understand. Non-collinear points means that they're not in a line. So an example here with this one would be maybe A, B, and C is not on the same line. So I could name it like that, and I would call it plane ABC. I could also name the plane with a capital letter. You guys can't see it because I kind of crossed it out there, but there's a capital letter in the top left corner there, capital K. I would call it plane capital K. Now, up top I said capital letters are points, right? But we're not going to assume that that's a point, mostly because there's not a point next to it. If there was a point next to it, you would know it's a point. But it's not. It's just a way to name that plane quickly. Continuing here, I'm going to define array next. Array is part of a line that goes forever in one direction, and that's it. So array is like a part of a line. Maybe we start here, but we go forever in one direction. What does that remind you of? It should remind you of like a ray of sunshine, for example. A ray of sunshine, right, here's your sun. A ray could extend off of that in exactly one direction, and they go really far, billions and billions of miles. So it does go pretty much indefinitely in one direction. That's why that would be called a ray. How to name a ray is a little tricky. We always, this one does matter, order does matter. For the other ones up top, it didn't really matter, but our order matters here. For array, we always go to the right with our arrow, and then you always have to figure out where is it starting and in what direction is it going. So where is this ray starting? Let me redraw my ray there. It's starting at B, so B has to be first. What direction is it going? Well, it's going in the direction of A, so that's one way I could write it. But it's also starting at B and going in the direction of E. And those two things would mean the same exact thing. Moving on to a line segment. A line segment is what you probably would have drawn if I asked you to come into class and draw a line on the board. It doesn't have arrows. It's a segment. If you think about a YouTube segment, it has a starting point and an ending point, or a news segment, or something like that. That's what the word segment means. It has starting and ending points. A segment could look like this one. Pretty straightforward. It's got starting and ending points at A and B. Okay, so a segment has 2 endpoints, A and B, and if I were to write that out, I would write it with a segment symbol with A and B, and that could be flipped around the other way as well. So you could call that BA. Notice I don't have arrows on top, and I will be calling those segments instead of lines because they are different things. If I go on to one of these questions, it's going to ask us to classify the figure as a line, array, or a segment, and then write it. The first one is a ray. I'll kind of just talk about why that is. It's got a starting point and then it goes forever in just one direction. If I were to write that, remember we always write our rays to the right. And then our starting point is D and it's going in the direction of C. There are some people, and we do give some problems that it points to the left, just to try to trick you, I guess. And some people like to write their rays to the left, and they'll still do it right. They'll go D, C like this. But that's not a proper way to write it, so that would be incorrect on a test. If I'm moving on, this looks like a segment because it's got starting and ending points. This one, it doesn't matter how you write it, so maybe I'll write it backwards this time. I'll go FE with a segment on top instead. For the last one, this is obviously a line. It's got two arrows on both sides, so I could call that AB or BA. I'll call it AB for this one, with a line on top. Okay, this next question is kind of confusing, so we're going to do our best here to explain kind of what this picture looks like first. First of all, I'll talk about what I see. I see a plane and I see two lines on it. The plane has a special name. I'm going to call it plane P. I can call it plane P because there's a P in the corner. It doesn't have a point attached to it. And then I can name this line, line N. I know that's a name for the line because it's lowercase. And same with this one, I could call this one line R, the line that's next to that, lowercase r there. After that, with these two lines, I kind of got to look and see what's going on. There's one you can kind of see that has a dashed line on it, and that's a good giveaway that it's kind of behind the plane. I shouldn't need that dashed line to be able to tell me that it's behind the plane, though, so I'm going to show you a different way that we would be able to know for sure that it's going behind the plane. Let's start with this line first, though, because it's a line that's directly on the plane, meaning if I were to draw a coordinate plane, all of those points would be on there. How do I know it's on the plane? Because this point's on the plane, this point, and this point. They're all within the bounds of that plane there. So all points are on the plane. That line is directly drawn on top of or sitting directly on the plane. For the other line, I'm looking at point T up there, and point T is not on the plane. So if you have a point that's above the plane, for example, that's what it looks like in this case. It's above the plane. And then you have a point X, which is on the plane, and these 2 points are connected by a line. That must mean that if there's a point off the plane and a point on the plane, that this line must go through the plane, which is really hard to understand, especially from this two-dimensional picture. But this is a three-dimensional object drawn onto a two-dimensional picture, which is really hard to do. So that's kind of how you have to draw it or think about it. If this one is off the plane, it must be going through the plane, kind of like if you took a pencil and stabbed it through your paper. That's what it would be looking like. Like this might be the eraser. I know that that's above the piece of paper. This is exactly the hole, and then this is maybe the tip of your pencil right at the bottom down there. So going through that, if I were to name a line containing point W, we're going to go real quickly through this. Naming a line containing point W, well, I could name that line, we already did kind of, as line N. I could also name it with 2 points and a line on top. So my line might be VX. VX contains that point W. I could have also named it VY or WX, or there's a variety of things I could have written there. Next, I'm going to name the plane containing point Z. So naming a plane is just the plane that it's talking about. Again, I can call that plane P, because that's in the corner. It's got a capital P in the corner there. I could also name it with 3 non-collinear points. So I could call it plane, I'll put slashes there, V, W, and Z is not on the same line as those, so that would work. Remind me to talk to you back when I get back in class on why they need to be non-collinear. Letter C, name a point not on plane P. Well, I can tell that T is not on there. Is N a point? I'm going to say no. My reasoning behind that would be it's lowercase and it doesn't have a point next to it. And then for the last one, it says which line is going through the plane. We already talked about that in depth. That would be, let me erase that quick. Line R is going through the plane. You could also call that line, what was that letter up there? TX, I believe. Make sure those are capitalized. throw a line on top. I actually didn't even need to write the word line in front because we put a line on top of it. So that's what I would do for those two. I might actually, I'll go quickly. When two lines cross, they cross at a point. That's a very common Algebra 1 standard that you guys have already talked about. Hopefully you figured out when two lines cross, where are they crossing? That would be at a point. If two planes cross, they'll go right through each other just like this, and a line is formed where they're touching. And then on this one, if you have a line going through a plane, that's kind of what this is showing up top, but it's more three-dimensional, so it's easier to see. But they would be touching at just exactly one point. So this would be, point. This is what we just did. Line, and then a point again. Okay, so we've got some practice here. This is an assignment. I'm going to let you guys try this one on your own. And I believe I'm just going to let you go ahead and do that. We're going to do our best today. And honestly, I'm not there to explain this super in depth. So if you have questions, I hope that you save them for me when I get back. But I will have you guys try these two homework assignments online. Good luck.